I'm going to discuss the printout of the difference machines. These are the 4 common machines available in Egypt. These machines can be spectral domain or swept source. They are applied to the discal peripapillary nerve fiber layer or the macular area. Area examined can be 6 by 6 or 7 by 7, or recently it can be wide area 12 by 9 millimeters. So we start with the Zeiss. This is the printout. So this is an example of optic disc cube 200 by 200. This means that in one line we have 200 A scans, and this is repeated 200 times, 200 B scans, to cover an area 6 by 6. Here this is the retinal nerve fiber layer thickness, and this is the thickness of the different layers. This is for both right and left eyes. Here we have the deviation map of the retinal nerve fiber layer. It's 50 by 50 superpixels. So 4 are joined together to form 1 superpixel. Area in gray means it is within normal. Area in yellow, it occurs in 5% of the normal. In red, occurs in 1% of the normal. Here, the Bruch's membrane endings. So this is the Bruch's membrane opening. You can see it here on the deviation map, this line. Then this is the internal limiting membrane. The minimal distance from the Bruch's membrane to the internal limiting membrane is determined. So in all around. This point here in the internal limiting membrane in the deviation map, this red line. In between we have the neural tissue. So the Bruch's membrane opening minimal rim width equals the neural tissue. So here this is the Bruch's membrane opening, and this is the neural tissue, the Bruch's membrane opening minimal rim width. And it is shown here for both eyes, right and left, compared to the normal. You need to check the Bruch's membrane opening. This is vertical and this is horizontal for both eyes. Then here, this is the Bruch's membrane opening. Then the software decide the center and start to draw a map 3.4 millimeters. Here you check the segmentation for each eye to be sure that it was properly done. It starts from temporal to superior to nasal to inferior. Here the both eyes are compared to the normal. So yellow means occurs in 5%, red occurs in 1% of the normal population. Here the hours or 4-quadrant thickness. This is the clue. Gray means that there is no that the values here are away from the beyond the normative data, or as in this example, it means that there is no normative data. So white means occur in 5% high, yellow in 5% low, red in 1% low. In this example, this is the macular area, macular cube. It can be 200 by 200, or as in this example, can be 512 by 128. Software measures the ganglion cell inner plexiform layer complex. So the area 6 by 6, but actually what is measured is an area 4 by 4 and 8 millimeters, and the inner part is 1.2 by 1 millimeter. Outside and inside, the thickness of the nerve of the ganglion cell is very thin, so the software cannot detect it. So this is actually the area where ganglion cells are measured. This is macular cube 212 by 128. Here you check segmentation to be sure it is correct. This is the thickness of the different eyes. This is the deviation map. And this is the sector thickness. A combined print can be shown showing the retinal fiber layer around the disc and the ganglion cells in the macula. This is the thickness. And here we have deviation map. Details about the value of this will be discussed in upcoming presentation. Now we move to the second machine, the Optiview. This is the printout of both eyes. Up here, the right eye, this is the left eye. This is the disc, this is the macular area. So here you have the disc area around the disc and the hour thickness of the circle. And here the value of right eye, value of left eye, and both are compared here, and if there is a difference it is shown here. The software have 13 circles starting from 1.3 up to 4.9 millimeter and 12 radial lines. Then this is the circle 3.4 millimeter. So here this is the edge of the disc. This is the cup. The area around the disc is 4 millimeters. And this is the 3.4 millimeter. The thickness is shown here in the hourly presented part. This is the ganglion cells of the macula. The software check 15 vertical lines covering an area 7 by 7. It measures ganglion cells, inner plexiform layer, and nerve fiber layer. This is known together as ganglion cell complex. Here you can have one of three things. It can be significance map, or it can be thickness, or it can be deviation map. Deviation map in black means there is 50% loss of the tissues here, 25% will be in blue. As usual, red means it occurs in 1%, yellow means occurs in 5%. New software can show section and the disc section in the macula to be sure of the segmentation. Here, comparison between both eyes, and these are here the different parameters of the retinal fiber layer, optic nerve head, and ganglion cell complex. Two specific parameters for this machine: focal loss volume and global loss volume. They are specific for glaucoma. Again, new software compare between the eyes, right and left, and you have differences here. Now we go to the third machine, the Topcon. Here it's 6 by 6 millimeters, scans 512 A scan, repeated 128 B scans to cover an area 6 by 6. This ring is shown here, thickness in hours or sectors, and here you have the nerve fiber layer thickness of both eyes compared to the normative data. Here the segmentation is checked. Here this is the end of the retinal pigment epithelium. The Topcon determine the end of the retinal pigment epithelium, then go up for 120 micron, then everything up that is neural tissue, and below it is the cup area. And you can see it's written here. The macular area 6 by 6 millimeters, 512 A scans, repeated 128 times B scans. As you notice here, this is the retinal nerve fiber layer, ganglion cell plus means ganglion cell plus inner plexiform layer, ganglion cell layer 2 pluses means retinal nerve fiber layer with the ganglion cell with the inner plexiform layer. Here you have superpixel with deviation maps. This is the thickness with the clue here. Then we have the average superior inferior total for the different layers, and then we have the comparison between upper and lower parts. In this example, there is different generations. So we have wide area 12 by 9 millimeter. This section, you can see it here. Horizontally, you can see it here, the disc and the macula. Then you have different thickness, whole retina, ganglion cell layer double plus, ganglion cell layer 1 plus, nerve fiber layer, deviation map. Another example of wide imaging, including disc and macula. You can see the segmentation. Here, nerve fiber layer, ganglion cell double plus, nerve fiber layer. Recently, a print includes the changes in the nerve fiber layer in the ganglion cells, and also in the field. All are displayed together. This is known as the Hood report, and I'm going to cover the details of this in upcoming presentation. Another example of Hood report. The last is the Heidelberg. The area examined 30 by 25 degrees. One more thing, the software locates the fovea and the Bruch's membrane opening, and the axis joining them is determined. The size of the area examined is 8 by 8 millimeter. So this is an example of the circle around the disc. You can check the segmentation. Each eye is shown separately, and comparison is shown here, and the difference thickness is shown there. A new software is available called Glaucoma Module Premium Edition. It shows parameters of the disc, the nerve fiber layer around the disc, the posterior pole, the different layers of the posterior pole. The ring, usually it is 3.5 millimeter, but it can be 4.1 or 4.7 if the operator choose a wider ring. This can be, the wider ring can be applied in case there is pathology and we wish to avoid, like in this example, medullated nerve fiber layer shown in the small ring, in the middle ring, and in the large ring, so you can avoid such a problem and get information of the nerve fiber layer. Here this is example of the 3.5 millimeter, one eye, second eye, comparing both eyes, and the different values are shown here. So different sections are shown, and the Bruch's membrane opening is defined. Internal limiting membrane, and minimal distance between Bruch's membrane and internal limiting membrane. Then you have the thickness of the neural tissue and the different layers for one eye, for the other eye, compared with the normative data, and the values are written here, and if they are outside the normal, then it is shown in red. The posterior pole asymmetry analysis, the thickness of all the layers, you can choose the whole retina or you can choose any layer of the different layers of the retina. Thickness will be shown here, and comparison between sections can be achieved. For example, here they are comparing thickness superior to inferior, and here inferior to superior. So in this sector are comparing superior to inferior, and in this sector comparing inferior to superior. So these are the values, and this is the comparison. Simply you start to check the gray or the dark part. This is the location of a problem. This can be done, the comparison can be done for the whole retina or for any individual layer of the different layers of the retina. So this is superior to inferior, and this is inferior to superior. So here have thickness thin compared to the upper part. So simply by looking, you can check and say, yes, I have problems in this part. The posterior pole asymmetry can be shown in color map or heat map. Heat map offers more continuous spectrum of color scale compared to the color map. So differences over the time can be determined easily. This can be found in any layer as the operator wishes to choose different layers of the retina. This is another example of asymmetry. Here we have asymmetry between right and left eye, right to left, and here left to right. In the lower part, you are comparing superior to inferior and inferior to superior. So simply, if you look here, we have a problem in the superior compared to the inferior. Right to left, you're comparing one segment, one square, with the corresponding square. Superior to inferior, comparing up with the lower. Inferior to superior, comparing the lower compared to the up. Another character of this software is the fovea bone membrane opening axis. The software decides the fovea, being the thin part, check the opening membrane opening, and determine this axis. This axis can be any degree between 6 degrees above the horizontal down to 17 degrees below the horizontal. Actually, after determining the exact axis of the patient, the software starts to rotate the image so that at the end, this axis should be 100% horizontal. So in this example, it is up. In this example, it is down. This is the perfect location. This is the 100% horizontal. Then the software will start to rotate the image, as here also, to be directly horizontal. This is an advantage because sometimes this rotation, this deviation is large, and this will affect the relation between what we see on the OCT compared to that of the field. Also, the Heidelberg recently included the hood glaucoma report. This is the section, this is the thickness, and this is the comparison with the field. The ganglion cells are compared with the central 10 degrees. The whole area nerve fiber layer are compared with the 24 degrees. Again, details of this will be covered in upcoming presentation. Finally, this table showing the differences between some of the modalities of the different OCT machines. Thank you for your attention.